In Module 2, Section 7, the last section of Module 2, we will discuss simplifying expressions. Before we can work problems where we are simplifying expressions, we have to define two terms, the word term and the word coefficient. A term in mathematics is a number or the product of a number and variables raised to powers. So we have four examples on the left side of terms. A constant, 7, is a term. 5x cubed, so a constant times a variable. Maybe a constant times multiple variables, as we see in the third example. Or a variable without a constant written. Now the coefficient is the constant that the variable is being multiplied by. The coefficient of a constant, in the case of 7, will be the constant. And so 7 is the coefficient of 7. 10 is the coefficient of 10, and so on. In the second term, where we have 5x cubed, the constant that we are multiplying the variable by is 5, so the coefficient is 5. A lot of times it will be the leading number once the term is simplified, once all of the factors that are constant have been multiplied together. Likewise, a negative 4xy squared, the constant that we are multiplying the variables by is negative 4. So that is the coefficient. And in the case of z squared or any variable where we don't have a constant that is written, it is always understood to be 1. Except in the case where we might have a negative variable. So let's say our term was negative x squared, then the coefficient would be negative 1. So let's go through the next four examples and identify the numerical coefficient of each term. Starting with example A, we have negative 6x, which is negative 6 times x. So the constant multiplier is negative 6. That is our coefficient. For example B, 27 z cubed is 27 times z cubed. So the constant multiplier is 27. That's our numerical coefficient. On example C, we have negative y, which can be rewritten as negative 1 times y. So the constant multiplier is negative 1. That is our coefficient. D might seem a little tricky. We have to rewrite the fraction so that we have a constant multiplier. X over 19 is the same as 1 over 19 times x. So anytime we have a variable in the numerator, we can write that as the second factor and put a 1 as the placeholder in the numerator. We can now see that 1 over 19 is the constant multiplier, so 1 over 19 is the numerical coefficient. Now that we have defined terms, let's define like terms. Like terms contain the same variables raised to the same powers. So we must have the same variables and the same powers. Terms that are not like terms are called unlike terms. Very creative people. Now once we can define and determine like terms, we can combine like terms. And the way we combine like terms is by combining the numerical coefficients and multiplying the result by the common variable factors. Before we try to combine like terms, let's see if we can recognize like terms. So let's determine if the terms listed in each example are like or unlike. In example A, we have 6x squared and 7x. We notice right away we have the same variable, but we don't have the same exponent. The exponent of the first term is 2. The exponent of the second term, it's not written, so it's understood to be 1. Because the exponents are not the same, these terms are unlike. For example B, we have 19xy and 30xy. The variables are the same. The exponents are the same, so these are considered like terms. For example C, we have 13xy and negative 7xy. Again, same variable, same exponent, so these are also like terms. Now that we are able to identify like terms and unlike terms, let's simplify each expression by combining like terms. So in example A, we have 6x squared plus 7x squared. We first look at the variable. The variable is x. The exponent is 2. So we have like terms. And in this case, we add or subtract the coefficient. In this case, we add because we have an addition symbol. So we're going to add 6 plus 7. And we're going to multiply by the common variable, x squared. 6 plus 7 is 13. 13 times x squared is 13x squared. Notice that the variable that we saw in the original terms is exactly the same. Adding and subtracting like terms will not change the variable. Let's try the next example. 19xy minus 30xy. We have the same variables, the same exponents, so we do have like terms, therefore we can combine the coefficients. 19 minus 30, we use the operation from the original problem. We're going to multiply by the common variable. 19 minus 30 is negative 11. Negative 11 times xy is negative 11xy. Again, the variable does not change. And in the last example, 13xy squared minus 7x squared y. Again, we have the same variable, but we do not have the same exponent. We have a y squared and a y to the first. We have an x squared and an x to the first. So because we can't combine these like terms, I'm just going to write exactly what we had. 13xy squared minus 7x squared y. Just like in the cases of fractions where sometimes they're already written in lowest terms, it's possible that we have no like terms to combine, so everything is simplified in the expression. Now let's find each product by using the distributive property to remove parentheses. So in these two examples, we'll first use the distributive property, and then, if possible or if necessary, we will combine like terms. So in example A, we will multiply 4 to each term inside parentheses. 4 times 5x will result in 20x plus 4 times 7 is 28. Because 20x and 28 are not like terms, that's as far as we can go. That's the solution. In example B, we're multiplying negative 3 times this set of parentheses. So I'm going to draw my arrow that represents I'm multiplying negative 3 times each term. So we start with negative 3 times x is negative 3x plus negative 3 times 0.5y is negative 1.5y minus negative 3 times 7 is negative 21. Now I went ahead and included the original operations of addition and subtraction so that you would know exactly where each value was coming from when I multiplied the negative 3. It was also perfectly fine to think of this negative 7 in the original, or this minus 7 as a negative 7, and go ahead and multiply negative 3 and negative 7. And if you did that, you would see you would end up with the same result after we simplify. So I rewrite the result as negative 3x. Now, plus a negative 1.5 is the same thing as minus 1.5y. Minus negative 21 is the same thing as plus positive 21. Of these three terms, none of them are like, so that is the simplified expression. Let's continue with what we've seen on the last two slides to simplify each of these expressions. So the first thing we will do to simplify is the distributive property. In example A, let's distribute the 4. 4 times 2x is 8x plus 4 times 1 is 4. 4 does not multiply to the minus 8 because the parentheses came to a close. So we bring down the minus 8. Now, unlike the last two examples, here we do have like terms after we distribute. 4 and negative 8 are both like terms. They're both constants. Neither of them have variables. So we can multiply these, we can subtract these. So in our result, we have 8x that had no like terms. Working out 4 minus 8 gives us negative 4. So I'm going to ignore the plus sign and just write minus 4. In example B, we must multiply 3 to each term inside parentheses. Doing so gives us 8 plus 3 times 3x is 9x. 3 times negative 4 is minus 12. It's okay to think of that as a negative 4 while you're multiplying, or to write the negative sign, the minus sign, and then multiply 3 times 4. You would end up with the same result. Here we also have like terms in 8 and the minus 12. So let's rearrange our terms just so that our like terms are beside one another. We have 9x plus 8 minus 12. Now we combine our like terms. That becomes 9x minus 4. Let's try another example where we are also using the distributive property and then combining like terms. Let's make one change to the original problem that we see. And instead of having a minus sign instead of the second set of parentheses, let's change that to a minus 1 so that we know we're actually distributing a negative 1 to each number in the set of parentheses that follows. So starting with 1/3, we multiply 1/3 to both terms in the first set of parentheses. That will give us 1/3 times 9z. Just want to write down the factors first, plus 1/3 times 12. Now at the same time, let's distribute the negative 1 to each term in the set of parentheses that follows. That will give us, I'll put a plus sign here, just to denote we have extra terms that are coming along. Negative 1 times z plus negative 1 times negative 5. Sometimes I will say minus when we indicate an operation. Sometimes I will say negative. Essentially, they mean the same thing. Minus a number, or treating that number like a negative number, that's more or less the same thing. It just depends on what we're talking about, a number or an operation. And they can be used interchangeably. At least I will use them interchangeably throughout these videos and throughout this course. Now that we have our 4 products that need to be simplified, let's go back to 1/3 times 9z. Whenever we have a fraction involved, everything wants to be a fraction. So we change 9 to a fraction by writing it as 9/1, and then we multiply numerators and denominators. 9 times 1 is 9, 3 times 1 is 3, and the z tags along, plus, let's change the 12 to a fraction, 12/1. 12 times 1 is 12, 3 times 1 is 3. Now the next operation, I'm not going to bring my plus sign down yet. I multiply negative 1 times z, and that gives me negative 1z. And I will rewrite that in a moment. It's okay to leave it as negative 1z, even in the answer. But we know that instead of writing negative 1z, we could write negative z. And sometimes it's better to leave that coefficient of 1 invisible. Now we move to our last product, negative 1 times negative 5. That is a positive 5. Now we need to clean up a few of our terms before we can combine like terms. 9/3 reduces to 3, so we have 3z plus 12/3 is 4. So 3z plus 4 minus 1z plus 5. Here we have 2 sets of like terms. I have 3z and negative 1z. I also have positive 4 and positive 5. If we combine our z's, 3z minus 1z, 3 minus 1 is 2. So it becomes 2z. Positive 4 plus positive 5 becomes positive 9. 2z and positive 9 are not like terms, so that is the end of the problem. Now that we know how to use the distributive property, how to combine like terms, let's write each phrase as an algebraic expression and simplify if possible. Sometimes it will be possible, sometimes it will not. So let's start with example A, twice a number plus 9. Twice means 2 times. Remember, x will always represent the unknown number in these particular problems. So twice a number, or 2 times x, plus, that's not a hard translation, plus 9. We can't combine 2 times x and 9, but we can rewrite it as 2x plus 9. And that will be as simplified as that expression can become. Let's look at the next expression. 7 times, so 7 times. Now whenever we see this phrase, the sum of, the difference of, and that's being multiplied by a number, we want to trap that sum or that difference in a set of parentheses. So 7 times the sum, you might also see the difference in certain scenarios, the sum of a number and 2. Now remember, sum means addition. We want to add a number and 2, but we must put this in parentheses. What we shouldn't do is put 7x plus 2. That is not the same. That will not give you the correct answer. So because we have a number that is being multiplied by a set of parentheses, we distribute the 7. 7 times the first term, 7 times the second term. And that will give us 7 times x is 7x plus 7 times 2 is 14. 7x and 14 are not like terms, so that is the simplified expression. Let's try one more example, just so that we have another opportunity to set up an expression that will use parentheses. So again, we write each phrase as an algebraic expression and simplify if possible. X will represent the unknown number. So starting with double a number. Remember, double means times 2. So double a number, 2 times a number, 2 times x, minus, here we see this phrase again, the sum. So we have an operation, and then we have the phrase the sum. Or we could have an operation and the phrase the difference. Whenever we see that, we need to make sure the second operation, in this case the sum, is put inside parentheses. So double a number, 2 times x, minus the sum, that told us we needed parentheses, of the number and 8. Sum is addition, so we're adding a number and 8. Anytime we have a minus sign in front of a set of parentheses, I like to rewrite that as a minus 1. So that I know I'm taking that minus 1 and distributing to both terms, or 3 or 4 terms, however many terms we have, in the following set of parentheses. So as we do that, let's rewrite the expression. 2 times x is 2x. Negative 1 times x is minus 1x. Negative 1 times 8 is minus 8. Now we combine like terms. We have 2x minus 1x. 2 minus 1 is 1. So we have 1x, which can be written as just x minus 8. Be careful with your parentheses while you work this homework. Make sure to ask questions if and when you have them, and do the best you can.